Okay, assume that the calories in a McDonald's Egg McMuffin is normally distributed random variable with a mean of 290 calories and a standard deviation of 14 calories. Now the first thing I realize is that it is normally distributed. The number of calories are normally distributed. I'm given the average of 290 and I'm given the standard deviation of 14 calories. So I can use the standard normal table to get probabilities of being in any subinterval of this random variable's distribution. So for question A, it says, what is the probability that a particular serving contains fewer than 300 calories? A particular serving contains fewer than 300 calories. So the random variable x, representing the number of calories in the Egg McMuffin, is less than or equal to 300. That interval is going to be, I'm going to shade that in red in the distribution, less than 300. The probability of being in that interval is the area under the density function above the interval. So we just need to find that area. Now to do that, we're going to translate the problem into standard normal. So I need to get the z-score for 300. So 300, how many standard deviations is that away from the mean at 290? How many 14s are there between those two? And this turns out to be 0.714, which I'm going to round to the nearest hundredth, 0.71. The resolution of the standard normal table in the textbook is to hundredths, so I'm going to go ahead and round that to 0.71. Now, looking that value up in the table is going to give me the area to the left of the 0.71 location, and if I look that up in the table, that is going to be 0.7611. So this area to the left is 0.7611. And to find that in the table, I look up 0.71 as 0.7 row and 0.01 column, so that gives me the 0.7611 in the table. That's the 0.7 row and the 0.01 column combined together to get 0.71, and the probability given in the table is 0.7611. And since the table reads to the left, and that's exactly the probability I want, this is going to be 0.7611, or approximately 76.1%. So what's the probability of a particular serving contains fewer than 300 calories? And there's a 76.1% probability of that happening. Okay, for B. B is more than 250. I'm going to go ahead and draw the distribution again. More than 250. 250. Well, let's see. Probability that X is, it says more than 250. Now 250 is to the left of 290, and the standard deviation is 14. So that's almost 3 standard deviations to the left. Let's check the z-score on that. How far away is 250 from 290? I know it's to the left, so this is going to be negative. How many standard units are there? And that calculates out to a negative 2.86. So yes, it's almost 3 to the left. So I'm going to put it way down here. So 250, and that is 2.86 standard deviations to the left. So its z-score location is a negative 2.86. Now I want the probability that the random variable is greater than 250. So I want to find the area over the interval, this interval here that I'm shading in, greater than 250. I want to find the area under the density function above that interval. That's going to be the probability that x is greater than 250. Now, the table does not read that way. The table always reads to the left. So when I look up a negative 2.86 in the table, that is going to be on down to row negative 2.8 and then across to column 0.06. So the table value, I'm going to shade in green here, is 0.0021. Now I want the area above the 250. I want the probability that x is going to be greater than 250. So I know that the entire area under the density function is 1. So all I have to do is take 1, subtract 0.0021, and I get 0.9979, or approximately 99.8%. So what's the probability that a serving will be in excess of 250 calories? Well, 99.8% probability of that happening. Notice the difference between A and B. The table always reads to the left. And so when I'm looking at these two problems, I can see the first one was answered by that value, but the second one, since I was looking at an interval that's going out to the right, I'm going to have to subtract the table value from 1 to get what I want. Okay, for part C. Part C says between 275 and 310. Between 275 and 310. So let me go ahead and draw it again. 290 in the middle. Standard deviation of 14. And the probability between 275, that x is between 275 and 310. Okay, 275 is going to be down here on the left, and 310 is going to be over on the right side of 290, and I want the probability between those two. So I'm talking about this interval, and the probability of being in that interval is the area under the density function above the interval. And now I need to get the z-scores. So the z-value for 275, how many standard deviations is that to the left of the 290? And that turns out to be a negative 1.07. And the z-score for the 310, how many standard deviations is that to the right of the 290? And that turns out to be 1.43. So, now if I look up negative 1.07 in the table, that goes down to row negative 1, and then across to column 0.07. And that is going to give me 0.1423. So from the table, the area to the left of the 275 is 0.1423. And if I look up 1.43 for the 310, that's a positive. 1.4 is the row, and then 0.3 is the column. That is a 0.9236. Now, I'm going to go ahead and shade that in blue. So the area to the left of the 310 all the way down, remember the table just reads to the left, that entire area is 0.9236. That's in row 1.4 and column 0.03 for the 1.43. Now, the red area is what I've shaded. That's the answer I want. So what I'm going to do is, well, to get that, I know the blue area and I know the green area, so what would you do? You'd subtract. I'll take the 0.9236 and subtract the 0.1423 to get the red shaded region, which is what I want. And that turns out to be 0.7813, or approximately 78.1%. So what's the probability that a serving will be somewhere between 275 calories and 310 calories? 78.1%. Now, the last one, 15% of McDonald's Egg McMuffins are more than how many calories? So with that, 15% are more than how many calories? We're talking about the upper end here. So we're given, this is actually, again, this is kind of a problem in reverse. We're given the probability or the percentage, and we're asked to find the interval. Usually in the first three problems in this one, A, B, and C, we were given an interval, and we were asked to find the probability. Now we're given a probability, and we're asked to find the interval. In other words, what is the calorie amount such that 15% of the servings or the Egg McMuffins are above that? Well, I still have the same distribution of 290 and standard deviation 14. What's going to relate all these values together to solve for x? Well, the formula that relates everything is the z-score. So I'd have x subtract 290 over 14. Now, the thing here is that I now have two unknowns. I don't have the x, but I also don't have the z. But I can get the z, because I know that the area in the lower part of this distribution from the x down has got to be 0.85. And with that value, I can go to the table and find a way of getting at least the z-score. So going to the standard normal table, I'm going to be, first of all, on the upper end, that x value is to the right of 290. So I'm going to be on the positive z side, and I'm going to try to get as close to 0.85 as I can. Now, looking in the middle part of the table there, I see that I can get pretty close to 0.85 in row 1.0. So in row 1.0, there is a 0.8485, and then there is a 0.8508, and then there is a 0.8531. Now, which 0.85 is somewhere in the middle of all that. So the closest one is really 0.8508, and that is in row 0.04. So in other words, I'm sorry, column 0.03, 0.04, and 0.05. So the value that is closest to 0.85 is the 0.8508, and that is in row 1.0 and column 0.04. So my z-score has to be 1.04 for the x value. So I'll have x minus 290 divided by 14. Now, multiplying both sides by 14, I have 1.04 times 14 is equal to x minus 290. And then what's the next thing you do is you add 290 to both sides. And that total there will be x. So I'm going to take 1.04 times 14 plus 290, and I get x is equal to 304.56. So what can I say? 15% of the Egg McMuffins will have calories in excess of 304, 305 calories. So that is the answer to D.